first of all, welcome to all my students to start to the new batch of 2026 year. Okay, so who are starting 2026 year, who are going to attempt the 10th board exams in 2026. I'm heartily welcome to you all. So from today onwards, we are going to start all the chapters for maths as well as science, each and every topic, exercise, and even examples, previous year questions, and so on. So I will be with you till 26 board exam. So if you have any doubts in between, if we can have various types of sessions, live sessions, even shorts, and in my channel there is also a post section where you can also find MCQ questions. Okay, so let's work together. I just want everyone to be interactive, because if you have any doubts, it's better to write in the comment section so that I can check and respond to you. Then only your doubts will get clarified. Okay, so make sure if you have any doubts, kindly mention in the comment section, and let's continue with our questions. Okay. So first of all, in this real numbers, first of all, let us understand what is real numbers, and then we'll go with the chapter, because in NCERT book I can see that in the previous year classes we already studied, and then they already started with prime numbers, but I don't want my students to get confused what are real numbers. So first I will give a small example, like what are real numbers first. So what are the main, the name suggests it is a real. Real means it exists, and we can feel it also. We can say in that way, exists in sense we can read it, and we can also visualize wherever the number is present. So simply, real numbers contains two types, which are, so real numbers itself is divided into two, which are rational and irrational. Okay, we'll discuss about irrational later. So just understand, inside rational we have one more thing which is called integers. Okay, and we represent it as z. So integers, I will say integers are the numbers which are having minus infinity to infinity, not in decimals, just as a numbers. Okay, like example, minus 9, it is an integer, plus 9 is an integer, plus 35 is an integer. Then we have whole numbers inside it. So what are whole numbers? Whole numbers are the ones starting from 0 to infinite. It does not have negative numbers. Okay, it only has positive numbers which starts from 0 to, not only positive, even 0 is an neutral, I can say, from 0 to infinite, which are all the numbers, those belongs to whole numbers. Just a minute. So 0 to infinity numbers are the whole numbers. Then we have inside another small subset which are natural numbers. So what are natural numbers? Which starts from 1 to infinite. So all this combined, it belongs to rational numbers. What about rational? What is in between it has? Whichever can be written in form of p by q, consider it as rational. Which cannot be written in form of p by q, then it is called as irrational. Irrational will cover it later once the exercise 1.1 is done. Then I will discuss more on irrational. Will cover about this one. Okay, now we'll study only about rationals. Inside rational, as I told you, we have integers. Inside integers we have whole. Inside whole we have natural numbers. Okay, so every natural numbers belongs to rational. Every whole numbers belong to rational. Every integers belong to rational. Okay, so if you go in reverse way, not all rational numbers are not integers, all integers are not whole numbers, all whole numbers are not natural numbers. Okay, so we have different types of numbers. First one is natural numbers. If you go from smallest, so what are natural numbers? Which starts from 1 to infinite. Then we have whole numbers. Only one number is different between natural numbers and whole numbers, which is nothing but 0. So from 0 to infinite comes under whole numbers. Then we have integers. So what are integers? just starts from minus infinite to infinite. Then we have the last one, which is rational numbers. So rational numbers are the one which can be written in form of p by q numbers. So all this comes under rational. So with respect to symbols, natural numbers are written as n, whole numbers are indicated as w, integers are indicated as z, rational numbers are indicated as q. These are the symbols. Okay, so we might have studied these in the previous classes, I know, but still, as per my knowledge, I just want to revise everyone that we have these types of numbers: natural, whole, integers and rational. So all these comes along with irrational numbers belongs to real numbers. Okay, so all this comes under real, and inside real we have two subsets, as I told you, rational and irrational. Irrational will cover after exercise 1.1 is done, but right now just consider about rational numbers. Okay, then we have another two types of numbers called prime and composite. Okay, I know we have other types of numbers which are even and odd, and I hope everyone, okay, let's read that part as well. We have other numbers which are first odd numbers, then we have even numbers, odd numbers not divisible by 2. So odd numbers are the ones which cannot be divisible by 2. For example, 3, 7, 15, all this comes under odd numbers. Even numbers, simple, just opposite case, which are divisible by 2. So any numbers which are divisible by 2 comes under even numbers. 2, 6, 8 and so on. Okay, then we have other numbers which are prime and composite. So what are prime numbers? Which has only one end itself as factors. So which is not divisible by any number is called prime, which is having more than 2 factors. More than 2 factors are called as composite. Okay, prime in itself, example, I can say it is 3, 13, 23. This comes under prime numbers. Composite numbers are easy, which are divisible by any prime number, like suppose 4, 6. If bigger numbers if I want to consider, then I can say 24, 250 and so on. All these comes under composite. So we have different sets which are odd numbers not divisible by 2, like 3, 5, 7, 9, 11, 13 and so on. For even numbers which are divisible by 2, like 2, 4, 6, 8 and so on, every two table, whichever is the number, that is even number. Prime number which is having one and itself as a factors, we'll discuss about factors again. And then we have composite numbers which are having more than 2 factors. Okay, so hope you understood the revision of all these topics. Now let's go to the important topic from real numbers chapter itself, that is from NCERT point of view. The topic is every number. Okay, so this is the fundamental theorem. It states that every composite number, the number which I told you, what is composite number which is having more than 2 factors. So what it is saying means every composite number can be expressed as a product of prime numbers, and this factorization is unique apart from the order in which the prime factors occur. So this is, I can say, important, but with respect to exam point of view, theorem statement is not important, but how it is happening, that is important. Okay, so what is the fundamental theorem of arithmetic? It is stating that every composite number can be expressed or factorized as a product of prime numbers, and this factorization is unique apart from the order in which the prime factors occur. So I will give a small example. If I say consider the number as 24. If you ask what are the factors, so what is a factor? Any number by which it can be divided is called factors. So factors of 24, if I want, I can say factors are It can be divisible by 2, it can be divisible by 3, 3 is 24, 4 6 is 24, 6 4 is 24, 12 2 is 24, and then 20, anything else, 8 table also is there. 8 3 is 24, 12 2 is 24, and 24. So among, we are using any of these, we can divide 24. Hence the factors are 2 3 4 6 12 and 24. But we want what they have mentioned here. This is important, product of primes, not composite numbers. Okay, if you see here 4 6 8 12 24, all these 3, all these 5 are composite numbers, only 2 and 3 are the prime numbers. Okay, but here they mention product of primes, not composites. So to find how to write in prime terms of prime, what is the method is prime factorization. The method is something like this. We have to write the number 24, check for the least positive number through which it can be divided. If I say 2 table, it can be divided, so 2 12 is 24. Again check with which table. 2 table I can divide it, 2 6 is 12, again 2 3 is 6, again 3 is a prime number, so it cannot be divided. So it is 2 into 2 into 2 into 3. So now I can write 24 as 2 into 2 into 2 into 3, or I can also say this is equal to 2 cube into 3. So this is the product of prime factors of 24. So I'm repeating this topic because this is very important to find LCM, HCF and all. So what is the prime factorization method? Means factors, first write it, but they are asking that every number can be written in terms of primes, not in all the factors. So for to find the number in terms of primes, what you have to do is write the number and start from the lowest, smallest prime number through which can be divided. Get the number. Again check for this number through which can be divided. Get the number. Until you get a prime number at the ending, we have to keep on dividing. So for 24 I got it is 2 into 2 into 2 into 3, which is 2 cube into 3. So what is the theorem? It is saying that every composite number can be written or expressed in the product of prime factors, and this factorization is unique. So this 2 cube into 3 will only exist for 24. For any other composite number if you take, this will not be same. It will be different. Okay. Okay, then we have HCF and LCM. So what is a HCF? Means product of smallest power of each common prime factor in the number, whereas LCM is product of the greatest power of each prime factor involved in the number. If you notice here, there is small difference. Each common prime factor is for HCF, and for LCM it is involved in the number. So this point I'm marking in red color because this is the main topic. Common prime factor, whereas here involved prime factor, involved in the numbers. Okay, so we have various methods, but first I will tell you how to use using prime factorization method. So for example, okay, I think we have example questions. Yeah, we have example questions, so I will cover in that part. Okay, so before let's solve is the example question. Consider the number 4 power n, where n is a natural number. Check whether there is an any value of n for which the 4 power n ends with digit 0. So first of all, to find a digit 0, then something like we have a suppose 50, this is ending with 0, or 60, this is ending with 0. So every ending with 0, you can simply say it is divisible by 10. Okay, so what are the prime factors of 10? Okay, I will write it here. If I say prime factors of 10, it is 2 into 5. Okay, so for every number which is ending with 0 has to have at least 1 2 and 1 5 as a prime factor. Okay, I'll write here, for a number to end with 0, it has to have, or it should have, two and 5 as prime factors. only when it is having 2 and 5 as the factors, then that number will end with 0, or else it will not end with 0. What about 4 power n? 4 power n, if you consider, what are the prime factors of 4? I can write the prime factors of 4 are factors of 4 are only 2, because it can be written in 2 power 2 whole power n, or simply 2 power 2n. So what is the number? Only factor which is 2. So therefore it will not end with 0. You have to say at the ending point place is not enough, so I will write it here. It will not end with 0. So what I told you, if you want any number to end with 0, it should have 2 and 5 as the prime factors. For example, I will take another number and explain you. So let's consider 250 as the number. So what are the prime factors of it? So let's write it. 250. If I divide by 2, 2 ones, 2 25s, and divide by 5, 5 25s are 125. Again 5, 5 5 is 25. So here if you notice, we have 2 into 5 power cube. So we have 2 as a prime factor and 5 as a 5 factor. Hence this will is ending with 0. But for 4 power n, we don't have the 5. We should have at least 1 2 and 1 5 factor, then only the number will end with 0. Okay, let's see the second example. Find the LCM and HCF. Okay, now I will explain how to find the LCM and HCF using, this is important, which method they are asking. If they ask prime factorization method, then you have to follow the procedure I am explaining here. If they didn't mention method, then we'll tell you the other two methods to solve LCM and HCF methods. Okay, so let's solve using prime factorization. What we have to do is first write 6 and 20 in terms of its prime factors. So what about 6? 6 I can write 2 into 3, that's it. So 2 into 3. What about 20? 2 tens are 20, again 10, 2 5s are 10. So it is 2 square into 5. Okay, now let's write first HCF, because HCF is easy when compared to LCM for prime factors. So HCF means, what was the definition they are saying? Product of the smallest powers of each common factor. So what is common in both? If you notice here, 2, only 2 is common. So simple, HCF is 2. You can say that I have 2 but I have 2 square. But what is the statement? Smallest power I need to consider, not the highest power. So we have two powers which are 2 and 2 square. So which is smallest between these two? 2 is the smallest. Hence HCF is 2. What about LCM? LCM statement is product of the greatest power involved in the numbers. So what are the involved? You have to write everything. So what are the involved here? We have 2, we have 3, we have 5. That's it. So what is highest of 2? Highest of 2 is 2 square. Highest of 3 only 3. Highest of 5 only 5. Hence the LCM is 4 into 3. 4 into 3 is 12. 12 5 is 60. Okay. HCF is common. LCM is not common. LCM is involved. Whichever the prime numbers are involved, you have to write it, and you have to write the highest powers. Okay. Anyway, we'll solve more questions. Let's see the another question. Find the HCF of two numbers by prime factorization method, hence find their LCM. Okay, so before that we have one property for two numbers. What is the property? Is that for two numbers, LCM into HCF is equal to product of them. So this is very important, and this will question come for at least 2 marks question in your board exam as well. LCM into HCF, always remember, for two numbers, not for 3 or 4 numbers. LCM into HCF for two numbers is equal to product of the numbers. Okay, so for this question we have to first find the HCF. So I will just write 96, 104. They have clearly mentioned prime factorization only. Okay, so I will use the prime factorization. 96, 104, I will write it here. 96, I can write it as 248 is 96, 224 is 48, 212 is 24, 26 is 12, 23 is 6. 1, 2, 3, 4, 5. 2 power 5, 2 power 5 into 3. What about 104? 252 is a 104, 226 is 52, 213 is a 26, 13, it is a prime number. So 2 cube into 13. So what is HCF? HCF I can say which is common. 2 is common. What is the least? For 2 power 5, 2 power 3. So least is 2 power 3. Hence HCF I got, which is 2 power 3, which is 8. But they're not asking only HCF. What they're asking, they're also asking to find LCM. The property what I have told you, LCM into HCF is equal to product of the two numbers. So HCF I got, which is 8 into LCM is equal to product of two numbers. What are the two numbers? 96 and 404. Okay, I'm sorry. It is 404. I did for 104. Okay, let me correct it. Four 2 table 202, again 2 table 101, 101. Let's check. 3 table is not possible, 4 table not possible, 7 1 is 7, 31. So that is not possible. 7 is done. Then 11 table will not happen. 13 table, let's check. 13 17. Okay, any number is not possible, so 101 is a prime number. So simply I can say 404 as 2 square into 101. Hence HCF now it becomes 2 square, which is 4. Okay, now it becomes 96 into 104, 4 into LCM is equal to 96 into 404. Just a 2 minutes.
Hello students, welcome to
Okay, let's continue. So here we have 4 into LCM is okay. So 4 into 101. So hence LCM becomes 101 into 96, 606 909. So 6969. So the LCM of this numbers is 9696. Okay, next move to the next one. Find the HCF and LCM. Okay, we have three numbers now. We have 6, 72 and 120. So what are the names? 6. We already know it is 2 into 3. 72. I can write it as 2 36, 2 18s, 2 9s, and 3 3s. 2 cube into 3 square. 120, 2 60s, 2 30s, 2 15s, and 3 5s. It is 2 cube into 3 into 5. 2 cube into 3 into 5. So first HCF. For all 3, if you take common, which is common here, only 2 and 3 is the common, and we have to consider the least. So that is HCF. LCM, I will just first write all the prime factors involved. So 2, 3, 5 are involved. Now let's see the highest. Highest of 2 is 2 cube. Highest of 3 is 3 square. Highest of 5 is 1. So 2 cube is 8. 8 into 9. 8 9 is 72. 72 into 5. 5 2 is 10. 7 5 is 35. 36. So the LCM is 360 and HCF is 6. Okay. Let's start the exercise questions from now on. So exercise questions, I will not solve all the questions because I want you guys also to try. So what I will do is, if you have 3 questions, here we have 5. So I will solve 3 questions. I want 2 as a homework. Okay, if you have 4, I will solve 3. Okay, in that way I will do it. So here I will solve 1, this one, and the last one. I want these 2 to be homework, 156 and 5005. Okay, so just try these 2 questions. I will help you how to solve other 3. I just want you to try these 2 and let me know your answers in this video and in the comment section. In the next video I'll definitely solve these 2 as well, and I will help you with the solutions. Okay, but I want you guys to try. So let's solve for 140. So what is the question? Express this number 1 of prime factor. So it is easy, just 140. I will write it here. 2 table, 2 7s are 40, 14. So 2 70 is 140, 2 35 is 70, 5 7s are 35. So it is 2 square into 5 into 7 is the expression for 140. What about 3825? So 3 8 plus 3 11, 11 plus 7. Okay, it is divisible by 3. So 3 1s are 3, 2 3 2 6, 22, 3 7s are 21, and 3 5s are 15. Again 3 table, the logic is, if you add all the numbers and if you divisible by 3, then it is divisible by 3. So 2 plus 1 is 3, 3 plus 7, 7 plus 3 is 10, 10 plus 5 is 15. So again divisible by 3, 3 4s are 12, 3 2s are 6, 3 5s are 15. Okay, now it's 6 plus 5, 3 table not possible, so 5 I will use it. 5 8s are 40, 5 5s are 25. Again 5 1s are 5, 35, 5 7s are 35. 17 is a prime number, so I will stop it here. It is 3 square into 5 square into 17. Okay, let's solve the last one. 7 4 2 9. It is not, it is an odd number, so 2 is not possible. What about 3? 7 plus 4 is 11, 11 plus 2 13, 13 plus 9 20. Even 3 is also not possible, so 5 is not possible. So what are the prime numbers? I will write it here. We have 2 3 5 7 11 13 17 19 23, and then 29, and then 31. So mostly between here itself you will get the answer. 2 is not possible, 3 is not possible, 5 is not possible, 7. Let's check for 7. 7 1 just 7, then 42, 7 6 is 42. If 7 is also not possible, 11 definitely will not be possible. What about 13? 13 table, 7 4 2 9. 13 5 is 65, 92, 13 7s, 13 8s, 13 8s, 7 3 7, 7 7. Okay, 13 7s 91. Okay, 7 is also not possible. Okay, so I think maybe 19 table it will be divisible. Okay, we have 17 as well in between. So let's check for 17. So this is the only method, there is no other go. We have to keep on trying one by one prime numbers and check whether the number is divisible or not. Okay, so just checking 13 is not done, so let's check for 17. 17 5 7 5 35 5 7 3 5 5 6 7 8. Okay. 17 fours, 7 4 28, 2 68, and then 62. 17 3 is a 51, 1 1 9. 17 sevens, 7 7 is 49, 4 7 is 7 8 9 10 11. Okay, again I'll get 7. So 17 I got it as 437. Okay, let's check for 437. 17 table 437 is possible or not. Let's see. 17 1 is 17, 17 2 is 34. Then I have 97. Okay, 97 not possible. So 17 is not divisible. Let's check for another prime number, which is 19. 19 437. 19 2 is 38. 57. 19 3 is 27. 2. Yes, 19 3 is 57. So it is 19 table. If I divide, I'll get 23. 23 also a prime number. So for 7429, I can say the numbers are 17 into 19 into 23. Okay, in this way just keep on trying for which prime number it is divisible and get for other two. I want you to solve 156 and 5005. In the next video, definitely I will tell you the solution for these two questions. Okay, let's see the next one. Second question. Find the LCM and HCF for the following pairs and verify LCM into HCF. Okay, so here we have three questions. I will solve first and third. So these two I will solve it. I want you to solve this question as a homework. Okay, so let's solve the first one, which is 26 91. So 26 I can write it as 2 into 13, and 91 5 7 7 7, so yes, 7 1 is 7, 7 3 is 21. So it is 2 into 13, and here it is 7 into 13. Okay, let's write for here as well. 336, it is a big number. Okay, let's solve it. 2 1 is 2, 2 6 is 12, 2 8 is 16, and 2 8 is 16, 2 4 is 8, 2 4 is 8, 2 2 is 4, 2 21s, 3 7s. So for 336 I will write here 1 2 3 4, 2 power 4 into 3 into 7. What about 54? 2 2 is 4, 2 7 is 14. Okay, and then 3 9 is 27, 3 3 is 9. It is 2 into 3 cube. Okay, this is for 336. This is 54. What about here? 26 and 91. So LCM of HCF of these two is 13, and LCM of these two is 2 into 7 into 13. What about here? HCF is, which is common, 2 and 3. HCF is 2 into 3. LCM 2 power 4 into 3 cube into 7 is LCM. Okay, you can solve these two numbers. So I'll solve one by one. It is 13 here and 14 into 13. 14 into 13, 3 4 is 12, 1 3 1 is 3, 4 1 4 is 4, 1 1 is 1, 182. 182 is LCM here, and here LCM is HCF is 6, and this is a big number here. Okay, let's keep it aside. what they are asking, they are also asking to verify whether these two are same. So for verification, 13 into 182 I need to find, that should be equal to 26 into 91. 13 into 182 I need to find, I need to confirm it with 26 and 91. I need to prove this. This is another question. This is 1. I'm solving both at the same time, and it is 3. Okay, but you solve it only once at a time. Okay, so here it is 6 into 2 power 4 into 3 cube into 7. 6 into 2 power 4 3 cube to 7. Okay, this I need to prove it equal to 336 into 54. Okay, I need to solve these two and make sure that both should be same. Let's solve one by one. 182 into 13, 3 2s are 6, 3 8s are 24, 2 3 1s are 3, 4 5, 1 2s are 2, 1 8s are 8, 1 1s are 1, 6 6, 13. So I got this answer as 2366. Now let's do for other. 26 into 91, 1 6 are 6, 1 2s are 2, 9 6 are 54, 5, 9 2s are 18, 18 plus 3 is 23. So I got the same answer, 2366. Hence verified that HCF into LCM is equal to product. Okay, same I need to solve for this. 6 into 2 power 4, 2 power 4 is 16 into 9 into 7. So 6 into, okay, this all right, it is 42 into 16 into 27. So these three I need to multiply, and then need to multiply these two to get both as same. I'll multiply one by one. 42 into 16, I'll do it first. 6 2 is 12, 1, 6 4 is 24, 25, and then this is 42. So we have 276, and then we need to multiply with other numbers, which is 27. So 7 2 is 14, 1, 7 7 is 49, 50, 7 6 is 42, 47, 2 2 is 4, 2 7 is 14, 1 2 6 is 12, 13. So this I got 4 4 11, 4 plus 4 8, 18142. Just cross checking. So I got 18144. Similarly, let's cross verify for these two. 336 54, 6 4 is 24, 2 3 6 is 12, 13 14, 1 3 3 is 4 3 is 12, 13, 5 6 is 33, 5 3 is 15, 6 17 18, 1 3 5 is 15, 16. So I got 44181. See, I got the same answer, which is 18144. So for any two numbers, LCM into HCF is always equal to product of the numbers. Let's solve the third question. So with this question, I will stop the video for today, and in tomorrow's video I'll continue with the fourth question. Okay, so here also this is homework, and these two I'll solve it now, and in the next video you can find these homework solutions as well. Okay, let's solve this faster because these are small numbers. 12 5 21, 12 15 21. I'll solve one by one. Okay, 12 15 21. So 12 is 2 into 2 into 4, which is 2 square. 4 into 3, 15 is easy, it is just 3 into 5. What about 21? Also it is easy, it is 3 into 7. They're asking LCM and HCF. So LCM is highest, which is, okay, let's try what are involved. 2 is involved, 3 is involved, 5 is involved, 7 is involved. Now let's see the highest. 2 square is the highest. Okay, so 2 square is 4, 4 3 is 12, 12 5 is 60, 65 is 420 is the LCM. And what about HCF? I need to write this common of all three. Only one, which is only 3. Okay, let's solve for third one. 8, I can write it as 2 into 2 into 2, so it is 2 cube. 9 is 3 square, and 25 is 5 square. So HCF is easy here. We don't have anything as common. So simply HCF is 1. Okay. And we have LCM. Answer is easy. It is 2 cube, 3 square, 5 square. I'll write the value here. 8. 8 into 9, 7, 8 9 is 72. 72 into 25 I need to do it. 72 into 25, 5 2 is a 10 1, 5 7 is 35, 36, 2 2 is a 4, and 2 7 is a 14, so it becomes 0, 8, 1 8 double 0. So 1800 is the LCM value for this question. Okay. So what is the fourth question? Given that HCF of two numbers is 9, then the LCM of this one. So for any two numbers, in the last video I have told you that LCM into HCF is always equal to product of those numbers. If it is two numbers, always remember, if it is only for two numbers, this will satisfy, that is LCM into HCF should be equal to the product of those two numbers. So what is HCF? HCF is 9. LCM they haven't told you, they are asking to find it out. HCF is 9. And what are the numbers? 306 and 657. So 9 table, if I divide 9, yes, it will get divided. 9 3 is 27 and 4 is 36. So LCM is equal to 34 into 657. So let's solve this value. 657, 34, 3 7 4 7 28, 2 5 4 20, 22, 4 6 24, 26, 3 7 21, 2, 3 5 15, 16, 17, 1, 3 6 18, 19. So if you add these two, you'll get 8, 3, 13, 12, 2. So it is 22338 is the final answer. Okay, this is easy question and this is very important question. This type of question will definitely come. They will give you LCM, HCF and the two numbers. They can ask you in either way. But this step is important. That is LCM into HCF is equal to product of those two numbers. Let's see fifth one. Check 6 power n can end with a digit 0 for any natural number. So answer should be no. Why? Because we have to write the statement for a number to end with digit 0, it should have two and 5 as factors. Okay, so what about 6 power n? What are the factors of 6? It is 2 into 3 whole power n. It does not have 5 in it. So answer is no. 6 power n will not end with 0. Okay, let's see the sixth question. Explain why this number and this number are composite numbers. Okay, let's do one by one. 7 into 11 into 13 plus 13. So if you notice here, what is common? 13 is common. So if I take 13 as common, I will get 7 into 11 plus 1. So which is nothing but 13 into 7 into 11 is 77 plus 1 is 78. So here itself you can see it has one number and 78 again can be distributed to some other factors. So you can say here it is having more than two factors. So composite. Okay, same statement will be applicable for second as well. So I'll do it here itself. So here if you notice 5 is common. So I'll take 5 as common. I can say it is 7 into 6 into 4 into 3 into 2 plus 1. So which is 5 into 7 6 is 42, 42 into 4. Okay, 42 into 4 into 6, 42 into 24. Okay, but I will stop it here itself. 42 into 24. Okay, wait, sorry. 42 into 24 plus 1 is also there. So here also I can stop. Why? Because it has 5 as well as this number as well. So here also it is having more than 2 factors. You might have why more than 2, because 1 is also a factor for this. I can simply multiply into 1, and the whole number again will be another number. So definitely it is having more factors. Okay, so that's why you can say the same statement, it is having more than 2 factors, including 1 and the number itself. Hence it is, these are not prime, these are composite numbers. Okay, what about 7th one? This is a case study type of question. There is a circular path around a sports field. Okay, we have a circular path. Sonia takes 18 minutes to drive one round of the field. Okay, so for one round, Sonia takes 18 minutes. Ravi takes 12 minutes. Suppose they both start at the same point at the same time and go in the same direction. So after how many minutes they will again meet at the same point. To solve these type of questions, what you have to do is you have to find LCM. So why? Because so 18 18 18, it is taking 18 minutes. For Ram, who is the other one, Ravi, is taking 12. So both should meet at the same point, means the LCM, that is these two should have the same multiple, and the least common multiple will be the common point where both will have the same value. Okay, so let's find the LCM of these two, which is 18 and 12. We'll do prime factorization method. 18 I can write it as 2 into 2 9, so 2 into 3 into 3, which is 2 into 3 square. What about 12? I can write it as 2 into 2 into 3, because 4 3s are 12. So LCM is equal to 2 square into 3 square, which is 4 9s are 36. So for every 36th minute, both will have the same value. You can also cross check how it is happening, because Sonia at 18th minute it is reaching here, and again another 18th minute it is reaching the same point. So Sonia at 36th minute it is reaching this point. What about Ravi? He is also first 12, he will reach again hit this point, again 24 he will again reach the same point, and again 36 he will reach the same point. So at 36th minute I can say both will be at the same starting point. Okay, so this at the final statement you can say that both will meet at 36th minute. Okay, so in this way all the questions of exercise 1.1 are done. So now what I will do is, as an additional point, I am going to discuss about other methods to solve LCM and HCF. Okay, it is not there in NCERT point of view, but still as a 10th class student you should know what is the other methods to solve LCM and HCF. You can say other method only one method is the other one. In HCF we have Euclid division. It is not in as per NCERT syllabus, but we will cross check if any new changes are coming. But right of now, this syllabus is not included, but still if they haven't mentioned in the question to use prime factorization method, then you can also use these methods to solve the question. Okay, for LCM it is very easy. For suppose the same question, it is there 18 and 12, right? I will do the same again. So what is the method? Means we have to write like this. Write all the numbers for which LCM we have to find, then check for only prime factors. So it is common in between these two. If I divide by 2, I will get 2 6 are 12, 2 9 are 18. So what is, if I divide by 2, yes we can divide, but only one will be, it's okay, we can do it. 2 3s are 6. If it is not dividing, just write it same way. Okay, now let's check for 3. 3 1s are 3, 3 3s are 9. So this is also prime. So what is remaining? 2 square into 3 square. So you got the same answer. So instead of solving in this way, this method is much faster when compared to solve. Okay, I am repeating the same method. I will do for other values. For LCM, which one I have found? Okay, here I found for 12, 15 and 21. We got the LCM as 420. Okay, let's solve the same. 12, 15 and 21. So here I can say by 3 if I divide, I will get the small. 3 4s are 12, 3 5s are 15, 3 7s are 21. Then I can divide 2 as 2 2s are 4. If it is not able to do, just write the same. Okay, now let's have an answer. 3 2s are 6, 6 2s are 12, 12 and 5s are 60, 67s are 420. See, I got the same value. Okay, if it is not getting divided, just write the same. If it is getting divided, then divide it. Okay, so one more I will do for LCM. Okay, for this question, okay, it's lengthy. Let's solve for, okay, here LCM of 6 and 20. Let's do it. LCM of 6 comma 20. So if I divide by 2, 2 3s are 6, 2 10s are 20. 10 is a composite number, so I will, okay, then 2 table, 2 ones, 2 5s are 10. So it is 2 3s are 6, 6 2s are 12, 12 5s are 60. Okay, in this way LCM of any set of numbers can be done within a shorter time. Okay, what about HCF? What is the other method of HCF? Is Euclid's division, they call it as. So what is HCF? Second method is, we'll see the same type of question which we solved. Okay, here we found the HCF as 2. Let's solve the same. 6 and 20, we need to get the same value, which is 2. So what we have to do is, for 6 and 20, first use the small values. So 6, inside write 20, try to divide it. So you will get 6 3s are 18. So which we are remaining? 2. Now let's divide 2 with, 2 table with 6. Okay, now we will get 2 3s are 6. We are getting the remainder as 0. So till remainder we are getting 0, I have to do it, and this is the HCF. And cross check that question, HCF value should be 2. Yes, you can see here HCF is 2. Same I will check for other values. Okay, for this question the HCF is 4. So I will do the same, 96 and 404. Let's solve this. HCF of 96 and 404, we have to get the answer as 4. Okay, let's try. 96 404. So 96, I will check for 4. 9 4 is 36, 3 9 4 is 36, 36 plus 3 396. Okay, so 96 4s 396, we will get 4 plus 4 8, and it is 96. Okay, just a minute. sorry, here it is 6 4 are 24 and 3 is 4, 36 38. Sorry for it. Okay, so it is 384. 96 4 are 384, so we'll get 20 96. Now 20 table 24 are 80, so we'll use the same. We got 80 here, then the remainder is 16, and then it is 20 now. 16 once 16, we got 4. Now again repeat with the 16. Now we'll get 4 4 is 16. So now we are getting the remainder 0. So till you are getting the remainder as 0, you have to just keep on changing the numbers. 20 96. Now 16 20. Now we got 4 16. So in this way I have to repeat it. Finally I got the same answer, which is 4. So instead of finding the factors and getting the final value, this method is much easier when compared to get the HCF of two values. And always remember, this division method is only applicable for two values, not for multiple. Whereas the LCM method, this is applicable for any number of values. Okay, these are the other methods to solve LCM and HCF. Hope you understood. I will solve another value question for HCF, the division method. Let's see if any question is there. Okay, we'll solve the same. 306 and 657. HCF of 306 and 657. So using division method I am going to solve this. 306 657. So let's do by 2. 6 2 is 12. I'll do it properly. 306 2 2 6 is 12, 2 3 is 6, 6 1 is 2. If I divide, I'll get 5 4. Okay, 306 45. Let's check for sevens. 7 4 is 22, 7 4 is 28, 30. Yes, this is closer. 300. Okay, now we'll get 6. Three not 6 657. Okay, so there is a mistake. Let me just cross check. 306 2 is 612. Okay, so 45. 306 47. I am doing this mistake. Sorry guys. Let's do this. 7 5 is 35. 3 7 4 is 28, 31. So we have to do 45 into 6 now. 4 6 is 24, 5 6 4 5 is 33, 6 4 is 24, 27. So it is 45 into 6 is 270. Now we will get 36 and 45. 36 once 36. I will get 9. Then it is 36. 9 4 is 36. So here it is 0. So when I am getting 0, this is the HCF. So here the HCF is 9. Okay. So HCF is completely on the division. So make sure doing the division properly. Okay. So in this way the second method of HCF and the LCM are being explained. So if you have any doubts with respect to exercise 1.1, any question, we kindly mention in the comment section so that I can check and answer those questions respectively. And the homework questions, as I mentioned, so those questions I'll try to explain in a live session. So thanks for watching, and I have mentioned the same thing, like I am ready to have one-on-one sessions for any, if any students want one-on-one online sessions. So kindly mention your details to this mail ID so that I can check and connect with you separately. Okay, so thanks for watching.